So now let's go ahead and consider quantifiers. Quantifiers for us quantify to what extent some sort of propositional function is true in terms of the variables by which it's defined. And as we saw previously, you can't just plug anything into a propositional function. And so first off, before talking about quantifiers contained in this particular section of Rosen, we need to first off talk about domains. So let's go ahead and define what a domain is. So a domain is a set of values that are considered as valid input into a propositional function. So what I mean as valid input, I mean that those are the different values that your variables in your propositional function can take on. So for example, if you were to see some propositional function right here defined as follows, x plus 1 equals 1 plus x, then a domain that we could consider for this particular propositional function could be something like, the set of all real numbers, or the set of all natural numbers, or integers, or anything like that. Fantastic. So that would be one possible domain. So x could take on any real number, and that would be considered as valid input to this particular propositional function. As another example, just like we saw in the previous video, we could define a propositional function as computer X is connected to computer Y right here. And so for this one, the domain is really going to depend on the context that you're talking about. So there are a bunch of different domains that you could think of. So one possible domain if, for example, you were talking about computers in the computer science department, is the set of all possible names of computers that are in the computer science department. I have no idea how many there are, but I'm going to take a random guess and say, I don't know, let's say 532. There we go. So this would be one possible domain for this particular propositional function right here. X and Y can take on any of these values right here, and that would be considered as valid input. But in different situations, you might be thinking about different kinds of domains. So for example, you could consider a domain that looked like this. So we have a whole big set of IP addresses right here. So this, for example, represents an entire subnet, for example. So the domain that you're talking about could change depending on whatever context that you are discussing your propositional function in. So considering what domain you're talking about for your propositional function will very much affect whether or not it takes on truth values of true or false, or even whether or not it's a properly defined propositional function. So domains are really important but unfortunately, they're often assumed from context. So oftentimes you will see different very complicated logical expressions that are given, and they don't actually explicitly express what the domain is because it's assumed by the surrounding context that you understand what the domain is for the particular propositional function that you're talking about. So domains are really important, but they're often sort of just assumed from context over here. Our second note, later on, if you read the syllabus, you'll note that we're going to talk about sets. And so domains are sets, which are just collections of objects where no object is repeated and there's no particular order on it. But when we talk about sets in more detail and set operations and stuff like that, we will wrap back around and talk about domains as well.